Welcome back to Database Internals Crashcasts. I'm Sheila, and I'm here with Victor to wrap up our chapter on database models. Before we dive in, I'd like to remind our listeners that if you're enjoying our podcast, please take a moment to rate us on your favorite podcast platform. Your support means the world to us.
That's right, Sheila. Your feedback helps us improve and reach more database enthusiasts. Now let's get into today's topic, the summary of database models. We've covered a lot of ground in this chapter, and today we'll tie it all together.
Absolutely, Victor. But before we start, I have a quiz question for our listeners. Here goes. In a social media application, which database model would be most suitable for storing and querying complex relationships between users, their posts, and their connections? Think about it, and we'll reveal the answer at the end of the episode.
That's an intriguing question, Sheila. It really makes you think about the strengths of different database models and how they apply to real-world scenarios. I'm sure our listeners will have some interesting theories. Let's break it down as we go through our summary.
Good idea, Victor. Let's start with a brief overview of the database models we've covered. Can you give us a quick recap?
Certainly, we've explored 5 main database models: hierarchical, network, relational, object-oriented, and NoSQL. Each of these models represents a different approach to organizing and managing data.
That's right. Now let's dive a bit deeper. Can you explain the hierarchical model and how it evolved into the network model?
Sure thing. The hierarchical model, one of the earliest database models, organizes data in a tree-like structure with parent-child relationships. Think of it like a family tree. However, it had limitations in representing complex relationships, which led to the development of the network model.
And the network model improved on this by allowing more complex relationships, right? How does this compare to the relational model that came next?
Exactly, Sheila. The network model allowed for more flexible relationships between data entities. However, the relational model, introduced by E.F. Codd in 1970, revolutionized database design. It organizes data into tables with rows and columns, allowing for more intuitive data representation and powerful querying capabilities using SQL, which stands for Structured Query Language.
That's fascinating. I remember when we discussed how the relational model became the dominant paradigm for decades. But then came the object-oriented and NoSQL models. Can you explain why these newer models were developed?
Of course, the object-oriented model was developed to better align with object-oriented programming languages, allowing for more natural representation of complex data structures. NoSQL models, on the other hand, emerged to address the needs of big data and real-time web applications, offering greater scalability and flexibility.
I see. So each model seems to have its own strengths and use cases. Could you give us some examples of where each model might be most appropriate?
Absolutely. Hierarchical models might still be used in systems with naturally hierarchical data, like file systems. Network models, while less common today, can be useful in complex manufacturing systems. Relational databases are ubiquitous in business applications, financial systems, and anywhere structured data and complex queries are needed.
And what about object-oriented and NoSQL databases?
Object-oriented databases are often used in engineering and scientific applications, as well as content management systems. NoSQL databases have found their niche in web applications, real-time analytics, and IoT scenarios where scalability and flexibility are crucial.
That's really helpful, Victor. I'm curious, what are some common misunderstandings people have about these different database models?
Great question, Sheila. One common misunderstanding is that newer models like NoSQL completely replace older ones like relational databases. In reality, each model has its place, and many modern systems use a combination of different database types. This approach is known as polyglot persistence, which simply means using multiple database technologies in a single system.
That's a great point. It's not about one model being universally better, but choosing the right tool for the job. Speaking of which, do you have any tips for our listeners on how to choose the right database model for their projects?
Absolutely. The key is to understand your data and your application's requirements. Consider factors like the structure of your data, the types of queries you'll need to perform, the scale of your data, and the consistency requirements. It's also important to think about future growth and potential changes in your data model.
Those are excellent tips, Victor. Now, before we wrap up, I think it's time to reveal the answer to our quiz question. The question was, in a social media application, which database model would be most suitable for storing and querying complex relationships between users, their posts, and their connections?
Ah yes, the quiz question. While there could be arguments for different models, a graph database, which is a type of NoSQL database, would be particularly well suited for this scenario. Graph databases excel at managing and querying complex relationships, making them ideal for social networks, recommendation engines, and similar applications where connections between entities are crucial.
That's a great explanation, Victor. To summarize what we've covered today, we've discussed the evolution of database models from hierarchical and network models to relational, object-oriented, and NoSQL models. We've explored their strengths, use cases, and the importance of choosing the right model for specific applications.
Exactly, Sheila. And remember, in the world of databases, there's rarely a one-size-fits-all solution. Understanding these different models gives developers and architects the tools to make informed decisions and build efficient, scalable systems.
Well said, Victor. That brings us to the end of our database models chapter. We hope our listeners found this summary helpful. If you did, please visit crashcasts.com and consider joining our Discord community. Your support on Patreon helps us keep producing high-quality content. Don't forget to subscribe and rate our podcast. It really does make a difference. Thank you for listening, and we'll see you in the next episode, where we'll be starting a new exciting chapter on database architecture.